Hello everyone. Previously we had went through this one. What do we call interface segregation principle, right? And the solid. So today we'll be going with the last topic, that is nothing but dependency inversion principle. The last one within the design principles, right? So we have went with a certain design principles as well as the coding principles as well. So we went with DRY, we have went with YAJNI, we have went with KISS principles as well, right? So now we'll be finishing it off today, right? So with the dependency inversion principle topic, right? So what does this one, let's come to the definition part. What does the definition say here? So the dependency inversion principle, DIP, states that high level modules should not depend on low level modules. Again, what does it say? High level modules should not depend on low level modules, but both should depend on the abstractions, right? So high level module shouldn't depend on low level modules, but both both of them have to depend on the abstractions. So that's what dependency inversion principle states basically, right? It ensures that the code is flexible, reusable, and easy to maintain, right? So this is about the definition part. So before getting into the example part, let me explain you, or let's discuss some of the important points regarding the same dependency inversion principle, right? So now in the traditional programming, high level class like the service directly depends on a low level class. We know this one, right? So whether it may be database or the file system, right? So again, in traditional programming, high level class directly depends on the low level class. We know this. This creates the tight coupling, meaning if the low level class changes, the high level class breaks. Break, I won't say it always break. It always breaks. Basically, the chances of the high level class breaking will be high, right? So that's what uh, I'm trying to say here, or I'm trying to convey here, right? So basically, dependency inversion principle suggests we should depend on interfaces or abstract classes instead of concrete implementations, right? So again, DIP, or the dependency inversion principle, suggests we should depend on interfaces or abstract classes instead of the concrete implementations, right? So this way, the high level module only knows about the abstraction, not the actual implementation. Again, this way, the high level module only knows about the abstraction, not the actual implementation, right? So this is fine. This makes the system more scalable, testable, and loosely coupled. This makes the system more scalable, testable, and loosely coupled. So these are some of the important points regarding the dependency inversion principle, right? So let's get into the example part. Let's try to understand the same thing with a very simple example. So here first, or the first step, let's define an abstraction. Meaning here we'll be going with the interface using Python's duck typing basically, right? So I'll just go with a class here. Let me name this one message sender. This is fine. So here this will be def. So this one will be send. This one will be self, comma message. So this is also fine, man. Within this method, send method. So let me go with the raise keyword. So this one, let me go with not implemented error. So this one will be subclass must implement send method, right? So this is fine, man. Now let's go with one more class here. Let's create the low level modules as well. With the high level modules, we have to create the low level modules as well, right? So let's go with the implementations part here. So I'll just go with class. So this one will be email sender. So this is fine. Let me pass the message sender, right? So this is fine. So within this class, again, let me go with send method. So for the interactive purpose, I'll just go with the print instead of the returning something, right? So I'll just go with print. So this one will be sending email, something that is relevant I'm giving within the strings here. So let me pass the parameter message here. This is fine. Now let's do one thing. I'll just go with one more class here. So this one will be class SMS sender, right? So this one will be SMS sender. Let me pass the message sender. This is fine. So now uh, let me go with send. This is fine. Send. This is fine. We have went with the self and message, right? So here uh, I'll go with print. So this one will be sending SMS. This is also fine. So let me pass the message here. Yep, this is fine, man. We have went with the three classes. This is fine. Now let's go with the step three. So let's create the high level module depending on the abstraction. So high level module means, so let's go with the class notification service. So this will be high level, right? So I'll just go with class notification service. So all this one, message sender, email sender, SMS sender, so these things need the notification, right? So this will be the high level module. We are creating high level module that is depending on the abstraction, right? So I'll just go with the high level service. So no need of space here. So this is fine. Within this class, let me go with the constructor or the initialization part here first. So I'll just go with init. So along with the self init sender. Mm, I just need sender here. So this one will be message sender as well. So I'll just go with self dot sender. So this one, let me assign this one to the sender. So this is fine, man. Now let me go with the method notify. So I'll just go with the def notify. So within this, I'll just pass self comma message, right? So this is fine. Within this method notify, so let me go with self dot sender dot this one send. This is fine. Message, right? So this is fine. Let me remove equals here. We have just passed message, right? So this is fine. Yeah. Finally, what we will do, let's go with the client code. So we are done with the classes, right? So we are done with creating the high level modules as well as the low level modules. Now let's go with the client code, meaning let's choose the implementation at runtime. So I'll just go with email service here. So I'll just go with notification service. This is nothing but notification service of, let me pass here email sender. So this is fine as well. Now let me go with email service dot notify. So let me give here notify. So this one will be hello via email. So this is fine. Now let me go with SMS service. So this is fine. Equals notification service. So this one, let me pass SMS sender. So this is fine. So I'll just go with SMS service dot notify. So this one will be service dot notify. So this one, let me give hello via SMS. Right. So we are done, man. We are done. So first here, let me explain you the code whatever we have written quickly, and then we can go to the output part, right? So here whatever message sender class I have written, this is our abstraction, nothing but the interface, right? So that declares the send method, basically. This one I'm speaking of. Fine. Now again, we have considered this one, what do we call email sender, this one. So basically this implements the send method for sending an email. Fine. Now let's move on with the third one, nothing but the SMS sender. So this implements the send method for sending the SMS as well. So see here, this is fine. Now we have written the notification service class. This is the high level module which depends only on the message sender, message sender, this one, right? So message sender abstraction, not on email or SMS directly. So this doesn't depend on SMS or the email class directly. It only depends on the message sender abstraction, the first one, this one, right? So this is fine. We know this one. So this is nothing but the init. This is initialization part. So this is the constructor that takes any object that follows the message sender const this one contract basically, right? Init is nothing but the initialization, or the this is nothing but the constructor part basically. We know this, right? So now we have went with the notify. This is nothing but we are making use of the abstraction, nothing but send method to send the notification, right? So this email service and SMS service, whatever I have written, so yeah, this one email service as well as the SMS service, whatever I have written. So email service is nothing but the high level module that uses email sender now, right? And same goes with the SMS service as well. So this is the high level module that uses the SMS sender now, right? So we are done with the this one coding part. So now if we run, we have to get the output sending email hello via email. Hello via email is the thing I have given here, this one. Sending email this one, sending email this part basically, right? So this one sending email hello via email, and second one we are going with sending SMS, right? So sending SMS here, this one sending SMS and hello via SMS. So this is the output that we need to get basically, right? So let's check. I give control J here, just give me a second. I'll just type Python followed by the file name. So let me come here, copy the file name dot py, right? So here see sending email hello via email, sending SMS hello via SMS. So we are done with this part, right? Sending email as well as the sending via SMS. So we are getting the absolute correct output, or we are getting the desired output, right? So sending email basically hello via email, that is nothing but the notification service. Notification service use the email sender class to send the message. Same goes with the SMS. The notification service used this instead of the email sender, it made use of the SMS sender, right? So this class SMS sender um, class SMS sender class, this one, just to send the message. So I hope this is done, man. Easy peasy. So this is fine. Now we are done with the D, nothing but the dependency inversion principle. So this is it for the inversion principle. Simple. Yeah. So basically, what's the key idea here? The high level notification service didn't care whether it was sending email or SMS, because it depends only on the message sender abstraction. This one notification service, which is a high level module, it directly depends on the message sender abstraction. It doesn't care for the this one low level modules like email sender or the SMS sender. It directly depends on the message sender abstraction, right? Simple, right? So we are done with this part, right? So we are done with the dependency, what do we call, uh, dependency inversion principle, right? So we are done with this part. So next we'll be discussing on the this one, what do you call, different important algorithms, right? So there are n number of algorithms that we need to know, whether it may be tortoise and hare algorithm and the linked list. There are so many algorithms that we know, that we need to know in the graph, whether it may be distrust algorithm, yeah, whether it may be many algorithms in the graph basically, right? So there are many algorithms in the graph, there are many algorithms in the linked list basically, and there are many this one hash map principles that we need to know. There are many algorithms that is related to the dynamic programming that we can make use of, right? So the important ones, very important ones, let's group them together and try to understand that first, right? So some 20 to 30 very important ones, algorithms, let's try to understand that one in the form of code basically, right? So let's code that one, let's try to understand the algorithm with the help of the example code as well, right? So let's do that, and then let's design some let's go with solving this one, what do we call, design problems, some important 30 to 40 design problems. First let's try to understand some this one, what do we call, important algorithms basically, right? So now I'm coding this one, and the LeetCode initially I used to code with JavaScript, right? So that account currently I'm not using, so I'm just going with the new account. So basically I'm coding only I used to code using the Java, completely Java, right? So I used to code with Java. Now I'm coding first two questions with Python and the last two questions with the Java, because Java is like the boss, you know. So in the competitive coding I make use of the Java itself. So I will go with Java for the this one, what do we call, hard problems. For the hard problems, definitely I'll be going with the Java itself, not the Python, for practicing purpose. So first two problems will be solving with Python itself, not the Java. First two problems will be going with the Python, and the third and fourth problem will be usually going with the Java. And the competitive coding problems, so for the contest, will be going with the Java itself. Will not go with any other programming language, not even Node.js. First I used to code with Node, so now will not go with the Node, or will be going with the Python. Will be going only with the Java. For the this one in the Codeforces as well as the Code right? So we'll be going only with the Java. Only for the LeetCode problems, to solve the LeetCode problems, I'm speaking of the contest. Basically the first two problems let's solve with the Python, and the third and fourth problems will be solving with the this one, what do we call, Java, right? So this is fine. I hope the concept of this one dependency inversion principle is completely clear, man. This is basically end of the playlist. Next, as I've said, we'll be discussing on the this one, some of the very important algorithms, right? So for now, this is it. Thanks for watching, guys.